Hello, good evening, good morning, good afternoon, whatever time you're watching this educational video about variables in kinematics, specifically in displacement, distance, speed, and velocity. Before anything else, I would like you to recall that the meaning of kinematics is, a branch of mechanics that focuses on motion alone. Okay, no force is included, so that's kinematics, motion of a mechanical object. And please do recall that displacement is a vector, velocity is also a vector, speed and distance is scalar quantity, so no need for direction. So we have a problem earlier in my first period class that somehow caused uh, misinterpretations of the problem. And honestly speaking, this is due to the problem itself. So as I tried to consolidate ideas from my, colleagues, and of course I also use uh, artificial intelligence to like check the problem itself. And yeah, I come up with this consolidated uh, information about the sample problem. The original problem, yeah, I used this problem 3 years already, and yeah, we had a lot of interpretations about this one, and it's okay because one thing that will help my student at some point is how they are going to manage to come up with the task of the problem or the needed variable to be solving the problem. Although this problem itself is a bit ambiguous, very vague, but at least they know how to manage or how to interpret in their own ways. So this time we will try to clean up this problem based on what I have gathered. This is the sample problem, the original one. A mechanical object moves from 4 unit to 12 unit eastward from rest and 15 units westward in a total period of 15 seconds. All right, the first statement, a mechanical object moves from 4 unit to 12 unit eastward, is easy to be understood. Okay, if we have our number line here, and the mechanical object moves from, it started from 4 units. So if this will be our origin, 0, the mechanical object moves from 4 unit. This is our 4 unit here. And then it moves from 4 unit to 12 unit eastward, meaning you just have to continue the counting from 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is now 12 12 unit. Okay, so from 4 to 12 units. That's the motion of the mechanical object from 4 unit to 12 unit eastward, going east. Okay, that's how we are going to interpret it at some point. It's different when the problem, tells you that the object is from 4 unit and then moves and then moves 12 unit eastward. So it will change the nature of the problem. So our original problem, a mechanical object moves from 4 unit to 12 unit eastward. It's uh, you know 4 unit to 12 unit eastward. This is what we're going to do. So from 4 units all the way to 12 unit eastward. But in this case, if this is going to be the condition, from 4 unit and then moves 12 units eastward, it will have another interpretation. For example, this is gonna be 0, then 1, 2, 3, 4 from 4 units, and then moves 12 units eastward. So we need to really count another 12 units eastward. So 4, we'll change the color. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is now the additional 12 units going east. So in this case, the new position or the new unit is from 5, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 unit. So from 4 unit to 16 unit, if this is our condition. From 4 unit and then moves 12 units eastward. Okay? Or like it's saying the object moves 12 units east from 4 unit. So in our original problem, let's go back 4 unit to 12 unit eastward. So it's just a continuation of 4 unit going 12 unit eastward. So the mechanical object just move 1, 2, 3, 4, 5, 6, 7, 8 units movement. Okay, from 4 to 12. In this case, this is 12 units movement from 4 to 16 units. I hope it makes sense. This is something that I need to, I consulted my colleagues in artificial intelligence. And yeah, this phrase caused the confusion from res. I decided to not include this one in our in the way how we interpret this problem. Okay? After moving from 4 units to 12 unit, it moves again westward, going to the left. So we will try to count 15 unit westward. Okay, let me clean this part first. It's fine now. And let's use another color to represent the moving of 15 units westward from the current position. So from 12, it will move 15 units westward. So we will count. Do not start the counting here at 12 unit. Do not do that. You will begin here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, include 0, 12, 13, 14, 15. There you go. So in our number line, the new or the last position will gonna be a negative 3 units from 0. This is negative 1, negative 2, and negative 3. Okay, so this is our final position. Moving from 4 to 12 units, and then moving west all the way to negative 3 units. So this is going to be the final position. And remember, we started here at 4 meters. So this is going to be the initial position. I hope it makes sense. And the total duration of this motion from 4 unit to 12 and then westward all the way to negative 3 of our number line, that's 15 units westward. It happened only in 15 seconds time. And let's figure out average speed and the average velocity. To get the average speed, this is as we agreed that this is the average speed. This is the symbol like S subscript AVE. Okay. And the formula to get the average speed is just the total distance over the time. Okay. And remember, distance is a scalar quantity, so no negative value or direction doesn't matter. So in our problem earlier, we have our first distance. Let's say D1 for first path or distance 1. So from 4, yeah, from 4 unit to 12 unit east or eastward. All you had to do in a number line, 4 units to 12, how many units are there? So to answer it even without doing the number line or tracing it using the number line, all you have to do is to just minus 12 unit. That's the last position in the first distance, and minus where it started, 4 unit. So the answer, you will have 8 unit. So that 4 unit to 12 unit, it's just 8 unit all in all. Now, it's not yet the end. We have distance 2, another motion. It started now from 8 unit, 8 unit only, and then the next motion is going west, 15 units, but we don't care about direction because we're dealing with distance, not displacement. So we just have to add 15 units. All in all, it's going to be 23 units. The first distance from 4 to 12 units, you will going to count that one using the number line. It will just give you 8 units. 12 minus 4 unit. And then in distance 2, from 8 units, then just add 15 units west. Do not use negative because we're dealing with distance here. And when you get the sum, it's 23 units. So this is going to be our total distance. We can substitute it here. Total distance is 23 units. So 23 units, do not forget the units. In this case, it is not being specified to be meters or kilometers. It used unit as the unit itself. The time, according to the problem, it's 15. So you just have to put 15 seconds here. To get the average speed, all you have to do is to divide 23 divided by 15, and you will have 1.53. Don't forget the unit. Units per second. This is our average speed. Now let's have the average velocity. Average velocity. This time it's no longer total distance, but it's going to be the displacement over specific time. This time we have displacement as our numerator in the formula. So we need to find displacement, or to get displacement, all you have to do is to do this simple formula. Final displacement minus initial displacement. How to know the initial displacement? It's very clear, or the original position, it started 4 units. So we have 4 unit here, positive. But how are we going to find the final displacement? Because we need that variable to get the displacement. In the first motion in distance 1, to get the distance 1, what we did is we subtract 4 from 12 unit, and we got 8 as the difference. This case, do not do it because we're dealing with the displacement. Okay? The 8 units is the distance traveled from 4 to 12 unit. So we have 8 units as the distance traveled. It's not the object's position. We need to consider that it still The object is moving from 4 to 12. We will use 12 unit since the object moved from 4 unit to 12 unit. So this is now the position of our mechanical object, 12 unit. And then it moves 15 units west. Okay, so west here means to the left. So we will be using negative 15 units. And in this case, our final position, negative 3 units. This is our final position. So negative 3 units. Remember in our number line, we ended in negative 3 position. So it makes sense. Now, let's substitute to our formula. The final displacement is negative 3 unit minus 4 unit as the initial displacement. All in all, we have negative. Since both are negative integers, let's add 4 and 3 and follow the sign negative. So our displacement is negative 7 unit. And to get the average velocity, we will substitute it in our displacement. Negative 7, displacement is negative 7 unit over 15 seconds as the time given in the problem. Negative 7 divided by 15, it's 0.47, rounded off, unit per second. This is our average velocity. Based on our new interpretation of the problem, we enhance it. We omitted some of the phrase that will make the problem ambiguous and decided to be interpreted in this way. So the answers, our average speed, it's 1.53 units per second, and our average velocity is 0.47 unit per second. These are our answers. I hope it makes sense. You can watch this video again in order for you to really grasp how to solve this kind of problem regarding kinematics. This is the end of the video. I hope you learned something. And yeah, don't forget to support so that it will give me motivation to somehow upload some contents like this for our convenience. Thank you so much for taking your time to really finish this video, and see you around until next time. Bye for now.